Jeanine's going to kick our program off. She has a first presentation. She's going to be talking about statewide water conditions and preparing for a potentially dry 2014. Jeanine?
Thank you, Jeff. So one correction on that intro, the statewide water planning program was a long time ago. Now I just do more fun stuff like droughts and lack of water. So, okay, why are we here today? Well, if we look at what's happened the last couple of years, and this is a 2-year snapshot, end of water year conditions throughout the West, we see that a lot of the West has been dry, California, and certainly the Colorado River Basin, which is also important for Southern California. And if you look at the map of California overall, you see that there's definitely a gradient of precipitation there. Although the north has been dry, the south has been drier. And I think many of you have experienced that in your own areas, the San Joaquin Valley and here in Southern California. So our last wet year was actually water year 2011. 2012, first dry year, but because 2011 had been wet, we had pretty good reservoir storage going into that, so, not a big issue. And this year, although it was a dry year, we actually started out this past water year 2013 with very wet conditions, record wet in fact, but then the faucet shut off around the middle of December and we actually experienced record dry through what would normally be the wetter part of our winter season. But this early wet start to the water year again helped replenish reservoir storage, which was a good thing. Of course, we know that the large water projects that take water off the Sierras, the State Water Project, Federal Central Valley Project, had less than ideal supplies for many of their customers, especially with respect to the federal project supplies that are delivered south of Delta. And that's a reflection of environmental regulatory constraints and reallocation of water for environmental purposes, as well as just the hydrology. This has also been, out of the past 14 years in the Colorado River Basin, 11 have been dry, so we've had a sustained long-term dry period on the Colorado River. However, because of the significant amount of storage in that river basin, there's no impacts to California and, frankly, a low probability of future shortages to California within the next few years. So one of the questions that we get asked at the state level all the time is, when does it stop being dry and when does it become a drought? And drought is really in the eye of the beholder. It's a function of impacts. The analogy that I always like to use to describe it is that it's like the difference between a recession and a depression. A recession is when your neighbor loses his job. A depression is when you lose your job. And the perception of dry and drought works the same. It's dry if you're just hearing weather reports and such that, well, it's been dry, etc., somebody else is having problems. But if you have full supplies, it really doesn't affect you too much. On the other hand, when your supplies start to feel tight, then suddenly, all of a sudden, it is a drought. So there are many different ways to define drought. A meteorologist, for example, might say that drought is a period of extended low precipitation, precipitation below average conditions. A hydrologist could say similar idea, but runoff instead of precip. We've all heard the term regulatory drought. It's tossed about a lot with respect to the conditions in the Bay Delta and the fact that things like fishery protection has caused production and deliveries to water users. So you hear the term regulatory drought used, and that's somewhat independent of hydrology. There are many different indices out there to measure drought. Many local water agencies, for example, have triggers that they might use in their water conservation plans that tend to be usually based on supply from their wholesaler, the status of their groundwater basin, those kinds of things. There's also the U.S. Drought Monitor, and I was going to include a Drought Monitor snapshot in this presentation, but the website is down because of the federal government shutdown. But if you've seen the U.S. Drought Monitor, which you see widely pictured, map of the United States, D1, D2, D3, D4, etc., that was a tool that was developed by the University of Nebraska, Lincoln, And because it was developed in Nebraska, it really focuses on conditions that affect non-irrigated agriculture, precipitation and soil moisture, and its attempt to characterize at a very widespread scale, i.e. the entire United States, what conditions look like. If you're an urban water supplier in California, it's almost meaningless because it really doesn't reflect water supply conditions. It's really more reflective of precip, and it wasn't designed to deal with the way that we move water around in California, where supplies come from many hundreds of miles distant, and it also doesn't incorporate groundwater. So when you see the drought monitor, it may actually look worse than it is for the water supply perspective. And you may have also seen, and another one I can't show because it was also a federal website, the USDA disaster designations. If you've ever seen that map, or you've heard something to the effect that the Secretary of Agriculture has said that, well, gee, every county in California is designated a drought disaster. That's a tool that they use for making financial assistance available to growers, and the trigger for it is very low. And it's somewhat unfortunate they use the term disaster because it's not the typical meaning of disaster that the person in the street would expect. It would be an example of a sector-based definition of drought, for example, because, of course, if you're a farmer and something went wrong, it's a disaster to your income, perhaps. But this illustrates that different sectors of the economy, urban water users, agricultural water users, livestock grazing, which is very reliant on only rainfall, have different perception of droughts, and this is why we say that drought is a function of impact, because if you have a lot of resources to mitigate the effects of water scarcity, it may not be that much, it's not the same level of impact to you as to someone who lacks those resources. And in California, we're fortunate to have many ways or tools to use in managing drought, much more so than many other states. For example, Texas and New Mexico have had very dry conditions the last couple of years. Up until very recently in Texas, they had small municipalities who had only 30 to 90 days worth of storage left in their municipal reservoirs. Now, obviously, that's a pretty severe crisis. What happened? They got some really big rain events, monsoonal activity, tropical storms, etc., and that's going to bring them out of it a little bit. In this last series of wet weather events that we had in the last month in that part of the world, the Elephant Butte Reservoir in New Mexico on the Rio Grande went from 4% full, notice that was 4%, not 40%, 4% full to a whopping 7% full. Now, what that really illustrates is these are areas where they do not have the tools we have in California. They don't have infrastructure that allows them to move water around. In many parts of that world, they don't have a lot of groundwater resources to use. So in California, we're very fortunate not only to have the physical infrastructure, but we also have an institutional infrastructure that does things such as facilitate water transfers, for example, which you cannot do nearly as easily in many other Western states. So in that respect, we're actually remember the example of Atlanta a few years ago when Atlanta was about to go to have a little war between Georgia and some of the neighboring states there? That's reflective of an area that's never had to cope with shortage or manage or plan for it. So you can take pride in the fact that we're well in advance of some of those areas. Now, from a state perspective, there are a few challenges that really jump out at the state of California level, and these are the ones I would highlight. Delta conveyance, we're all very familiar with the issues associated with trying to move water across the Sacramento-San Joaquin Delta at the same time trying to restore the ecosystem and manage for multiple values there. I'm not going to talk too much about this one because this is very familiar to you. I'm going to be concentrating more on the other two topics. So just a few points to keep in mind. Drought happens. We know that. It's a normal part of the hydrologic cycle. And we have lots of warning. This is not an emergency like a flood or a forest fire or an earthquake where suddenly it happens and you have to respond. Droughts develop over multiple years, and we have lots of time to implement response activities like water conservation, like water transfers, water exchanges, etc. And as I mentioned, drought is not one size fits all. It affects different people differently. For example, people relying on what we call unmanaged water, that would be non-irrigated agriculture, and grazing is the big example. They're affected right away because they have no tools to deal with it. And in fact, the USDA disaster designation conditions that I mentioned are really driven by grazing. I mean, you can have a disaster designation for Alameda County. Now, Alameda County, agriculture, Oakland, think about that. But what it really means is that somewhere in the county there was some non-irrigated grazing land that, wasn't doing well. But really, and something that many people don't understand, and something I try to highlight when I talk to groups, is that the biggest economic impacts of drought that we've seen in California come from wildfire. They come from damages due to wildfire, and they come from loss of the timber resources. If you think back to the 87 to 92 drought, for example, throughout the Sierra Nevada, the national forest there were huge losses in terms of the dollar value of timber in that forest. And then the state's largest wildfire disasters, both in Southern California, 2003, following several drought years, and 2007, a very dry year, huge economic damages from those wildfires, in part because here in Southern California you have so much development right at the wildland interface. So I'm going to come back to this wildfire issue a little bit more in the talk. So basically how much you're affected in a drought depends on your ability to afford reliability. Urban water users can do things like water recycling projects or desal projects that are very useful as a drought mitigation and response measure. Small water systems, this is really the big problem. Small water systems on unreliable groundwater sources, and yes, you do have them in Southern California. This includes the foothills of the Sierra Nevada, some areas along the north and central coast, but it also includes places like eastern San Diego County, foothills of Inland Empire. These systems are where we have the most problems. Large water agencies, such as where most of you are coming from, can really handle 3 to 4 dry years with minimal impacts. And in fact, today, at the end of a second dry year, there's literally only a handful of municipal systems in California that have even called for voluntary conservation, clearly reflecting the fact that we've had good storage conditions, good groundwater, and people are well prepared for this. Now, this is just a snapshot of what the current situation looks like at the end of the last water year. So, reservoir storage starting to come down, but still actually not too bad, and I'll get to that in a moment. But big picture here for Southern California, the one thing we call out is San Luis Reservoir, which John Leahy may talk about in his remarks a little bit, but it's particularly low, and that's important because it's a source of water for the state, for state water project deliveries, which of course is water coming down this way. So let's talk about groundwater. I'm going to have a series of groundwater maps here. So here's a single dry year. This is a change in water levels between the spring of 2012 and spring of 2011. So first dry year to a wet year. Red dots decline, so the warmer colors represent declines. Here's 2 years. Or here's a second dry year, 2013 to 2012. More red. Anybody guess on where that red is? That's where we have most of the largest percentage of overdraft in California is occurring down in that part of the world. Now, here, same slide, 2013 to 2012, change the scale now. So red is more than 50 feet decline in groundwater levels. So going back, there's a more moderate scale where red is only 10 feet. And here's 50 feet. So what's going on in the south end of the San Joaquin Valley really stands out here. And it's not a huge surprise because we know this is an area where there's been long-term overdraft conditions of groundwater. And just to put in a plug for our CASGEM, the California Statewide Groundwater Elevation Monitoring System, was established by 2009 legislation and requires those of you who are local agencies that overlie groundwater basins to report water level data to the state. You can get the data on this website, and for those of you who are submitting data, we very much appreciate it, and thank you, because this is what allows us to take a look at groundwater at a statewide level. And we know that groundwater is a very important element in drought response. Average years about 30% of the state's water supply, about 40% in dry years. So what about the coming water year? Well, I mentioned that from our perspective, one of the big challenges in drought management is the fact that we can't predict when we're going to have dry conditions. So every year the department has been holding a Winter Outlook workshop, which is an experimental research forecast in which we bring together some of the scientists at Scripps and get together and talk about what we expect to see. We then publish a summary of that on our website. Unfortunately, the capacity for drought prediction, or intra-seasonal to interannual climate forecasting, to be more precise, is not really good. The strongest predictive ability that they have is the status of ENSO, El Nino Southern Oscillation conditions, out in the Pacific Ocean. This year it looks like ENSO may be neutral, which really takes away most of the value of that predictive capability. So it's really going to be pretty much a coin toss as to what this year could be. So, you know, while we would hope it would not be dry again, we can't predict that, so we need to plan for what if 2014 is dry. Now, as we go into this year, we know that we're going to have generally dry antecedent conditions, so even if we got, you know, average runoff, let's say, a lot of that will be lost to dry replenishing soil moisture, those kinds of things. So even if we had average precip, we would not expect to have average runoff. We know that storage in groundwater basins has been depleted, especially in some of the fractured rock basins that are critical for small water systems. And we know that in areas where there have been wildfires, and fortunately Southern California has not had a hugely active wildfire year, you have a high potential for mud and debris flows and after effects of that, as we saw after the 2007 wildfires down here. And we'll hear more about the San Francisco experience later on in the agenda. So actually going into, or end of last water year, going into this water year, we're at about 78% of statewide reservoir storage, which actually isn't too bad for a second consecutive dry year. The Colorado River Basin remains dry, but as I mentioned, that's not going to be a problem for us in terms of supply next year. Soil moisture is depleted. That's an issue in terms of wildfire risk, affects the grazing community, those kinds of folks. And of course, we always have the delta export capability that I think John will probably talk more about. So this is just a snapshot of calculated soil moisture across the U.S. And the scale is a little bit deceptive on this USDA figure because between 30 and 70% is white. So this isn't as good as you might think. So basically what it says that unless you're in Maine, soil moisture was fairly deficient in most of the places where this graphic was calculated. And in particular, notice we have that large area of really, really low soil moisture in Southern California. So what are the biggest risks if 2014 is dry? Well, as I mentioned, wildfire is actually the biggest economic risk in terms of its impacts, and of course, public health and safety impacts. Small water systems. Now, everyone probably has a different image in mind of small water systems, but frankly, small water systems in the neighborhood of less than 500 connections, few hundred connections, 50 connections, many of those systems struggle to maintain water supplies even in wet years, let alone average or dry years. They tend to be located in areas outside of a large municipal provider. They often have fractured rock groundwater sources, which tend to be quite unreliable. And actually, wildfire is a huge threat to small water systems. In the 2007-2009 drought that we experienced a few years ago, the last state water bond had provided an emergency fund to CDPH for emergency assistance for basically smaller water systems. Half of the money in that account went to systems who lost infrastructure in wildfires. Small systems who lost infrastructure in wildfires, lost an electrical system, lost pumps, storage tank was affected, those kinds of things. So these guys are really at a high risk during dry conditions. And then in terms of the bigger water systems, of course, we know that the Central Valley Project deliveries south of the Delta, i.e. the Westlands Water District area, for example, have had almost a new normal with respect to water supply conditions ever since 1991 when the Central Valley Project Improvement Act was enacted. That combined with the environmental requirements for fishery protection and such mean that even in a normal year they would not get 100% supply. And in fact, with respect to CVP south of Delta, they've only had a 100% supply in 3 years since 1990. And you know, you've probably may have seen the articles in the press that the Bureau has said that their initial allocations, even if it's average hydrology this season, would probably be 0 for the Central Valley project south of Delta. So big impact for that farming community. So in terms of the drinking water side, this really is the small system problem. I can literally take a map of California and draw X's on where we're going to start getting the calls, or where CDPH will start getting the calls. Some areas on the North Coast, some areas on the Central Coast, from about Santa Cruz on down, and then again these fractured rock groundwater basins. And that's why we spend a lot of effort thinking about how can we help these small systems, which is really a daunting task when you consider that, you know, they have no financial capability. Many of them only have 1 or 2 people on staff. They're too small to have conservation programs. It's quite a challenge. And I really want to emphasize the wildfire issue. Yeah, if you're served by a small water system, stock up on bottled water now. But you know, I think the Denver water experience. I mean, you know, systems in the order of a few hundred connections. The Denver water experience and their wildfires and the Hayman fire of 2002 was, I think, a wake up for that area, where they had massive wildfires like we had in Southern California in 2003 and 2007, and it really affected the water infrastructure of a major urban area. And I think that was a kind of significant first for them. And so this year we had the experience in Yosemite. I'm very glad that SFPUC is here today to talk to us about that. But for folks around the, you know, the rim communities here in Southern California, you know you have a wildfire risk, which in many cases could be translated as, you know, the mudslides and debris flow issues. But for the small water systems, this is where they lose a lot of infrastructure. And in fact, in the 2007 wildfires, there were a lot of small systems in eastern San Diego County that were basically out of business for a while due to the wildfire impacts. So just to wrap up now, to talk about what's DWR planning in terms of if 2014 is dry. Well, one of the things we do is, you know, we go out and do these outreach events, and in fact some of our staff today are doing a training class for small water systems in Palmdale. We've gotten some federal funding to partner with the California Rural Water Association, and we've been doing drought preparedness training for these very small systems, many of whom don't even know how to measure the water level in their wells, as sad as that would sound. We are very grateful to have the data that you all are submitting to the CASGEM program for groundwater, because it allows us to monitor impacts. And we're in the process of doing a contract with the Jet Propulsion Lab to use satellite-based radar technology to update subsidence monitoring in the San Joaquin Valley. That slide I showed you that had the 50-foot groundwater level drops in 1 year is indicative of high potential for subsidence problems. We know that areas like the San Joaquin Valley have a high subsidence risk already, and in fact there's some places in the valley where in the last 2 years we've lost 2 feet of elevation. And if you happen to have a flood control bypass project in the San Joaquin Valley and your levees had 2 feet of freeboard, well, guess what? That's not necessarily a good thing. So we're very concerned about keeping an eye on the impacts of subsidence on critical infrastructure. I mentioned that we do these research climate forecasts. There was a governor's executive order issued on facilitating water transfers this year, focused especially on the needs in the San Joaquin Valley, and this is work that will be ongoing. And then we're tracking the impacts of dry conditions with an eye towards seeing what happens if next year is dry. You know, statistically speaking, if you just looked at probability, you could say we maybe have about a 33% chance of a dry year, right? You know, 3 options, wet, dry, or average. Well, okay, purely on probability. However, we know that Mother Nature doesn't work that way. Unfortunately, we haven't been able to predict how Mother Nature is going to work, so, you know, we're at the point where we say that we hope for the best, but we need to prepare for the worst. So that's it, and I guess if there's time for questions, I might take 1 or 2.
is there also, are they using the NDVI or any other remote sensing to look at the water content in some of the drier areas?
Yeah, there's a number of techniques to look at the effects of dry conditions on vegetation, which is what you mentioned, the vegetation index. And the USDA, for example, funds a number of activities associated with that. And in fact, on the ag side of that, we partner with NASA Ames, and we're working with NASA Ames and NASS, the National Agricultural Statistics Service, to do a pilot project to use remote sensing to estimate acreage of fallowed ag land in the during the growing season in the Central Valley, which would be very useful for tracking ag impacts. So there are actually many satellite-based products out there for looking at vegetation conditions. And we also have another partnership with NASA where we've I don't know if you're familiar with our CIMUS, our California Irrigation Management Information System. We have something called Spatial CIMUS, where we basically use the information from remote sensing to extrapolate or interpolate, if you will, the on-the-ground network that we have from the 120 or so ground-based CIMUS weather stations that they have. So you can actually go to your cell phone and get a CIMUS data product on a 2-kilometer grid scale. Other questions? Yeah.
On one of your slides, you said 5% of the state public water system subject to the urban water plan. What's the population coverage?
Well, you know, it's really it's the 95%, 5% rule. So 95% or more or less of the state's population is served by 5% of the state's water systems, if you want to think of it that way. But 95% of the state's water systems are small systems. And that's where CDPH really struggles in terms of the enforcement actions and violations and all those problems with these really small systems.
Can I ask you the question, the last statement, evaluating the need to convene a state agency coordination committee in early 2014. It always seems to be somewhat of a question mark about whether we're really in a drought and it's a time to begin this and that, and each one is looking at the other, and understand that I'm from a very small water agency that's very dependent upon the Colorado River water and the Delta water. So how do you make it happen that you address this very thing immediately?
Well, you know, as I mentioned, for the big water systems, 3 to 4 years typically not a real issue in terms of impacts, except maybe in terms of ratepayer impacts if you have to enhance conservation programs or do water transfers. But really in the early, shall we say, onset of dry conditions, you know, we're looking for where are the impacts going to occur first, and the small water system example I was talking about is one where there's been a lot of interest in seeing how we can better help small water systems both on the quality and quantity side. You notice there was in the legislature this year, there was quite a debate about the way the existing state programs were dealing with the water quality impacts to small systems like in the San Joaquin Valley, the disadvantaged communities, nitrate, arsenic, etc. The system that we have now tends to favor, on the Safe Drinking Water Act side, providing the financial assistance to the larger systems where more population is served. But on the other hand, you have really severe impacts on the water quality side in the really small systems. And so one of the things that we've been discussing at multiple levels or multiple state agencies is there a way to better deal with managing the small water system problems, because that's where the first real impacts happen.
In your last slide, also you have a bullet item says facilitating water transfers. That doesn't mean that I was just wondering if the department provides any funding for the specifically small ones.
For water transfers, no. Most of the bond assistance programs that we have are focused on IRWM at a regional scale, and what the governor's executive order on water transfers called for was trying to improve the process and procedures, the coordination between, say, the State Water Project and Central Valley Project to be able to physically move water that was being purchased by others while ensuring compliance with the relevant environmental requirements.
Jeanine, thank you so much.